Assalamu alaikum. Am I audible?
Walaikum assalam.
Walaikum
Yes, sir,
assalam,
you are
sir. Yes,
audible.
you are audible.
Any doubt from last class?
No, sir.
Okay. So I defined you different concepts related to internal energy, heat, and work done. So next we have to start with thermodynamical process. First is isochoric. Isobaric, which is also called Charles law. Iso means same, bar defines you for pressure. So you will say the process which is carried out at constant pressure is called isobaric process. The process which is carried out at constant pressure is called isobaric process. So in this part, we have pressure constant. So according to ideal gas equation, PV equals to nRT. So if P is constant, so volume and temperature will be directly proportional to each other. So we can write equation of state related to this part, volume directly proportional to temperature. So V1 divided by T1 equals to V2 divided by T2. So this will be equation of state related to this part. Next, we have to find molar specific heat related to this process. So for general expression, P V to the power x is equals to constant. So what should be the value of x so that the component volume part will get vanished out and you're left with just P equals to constant. So you'll say x must be 0 here so that volume to the power 0 will be 1. So you're left with P equals to constant. So x will be 0. So using this, we may write molar specific heat at constant pressure. So C equals to R divided by gamma minus 1 minus R divided by x minus 1. X in this part is 0. So if you simplify it, you will get gamma times R divided by gamma minus 1. In terms of degree of freedom, it will be 1 plus F by 2 times R. And since this particular process is isobaric process, so C will be termed as Cp. Hamza, is it clear?
Yes, sir.
Next, we have to define indicator diagram related to this process. It means plot various other graphs related to pressure versus volume, pressure versus temperature, or volume versus temperature related to this process, which are called indicator or simply phasor diagram. First one, pressure versus volume. Second one, pressure versus temperature. And third one, volume versus temperature. Since pressure is constant, so it will be a straight line parallel to opposite axis. So graph will be like this, straight line parallel to opposite axis. Similarly, in second part, it will be a straight line parallel to opposite axis. But in third part, volume and temperature is directly proportional, so it will be a straight line from origin like this. First, write it down to this part, then I'm defining a different part related to this graph. You all have done? Salman? Hamza, done?
Yes, sir. Done.
Okay. Now we have to plot related to this process 6 different graphs. 3 will be for expansion and 3 will be for compression. So I'm defining only 3 parts, that is expansion part. So in first graph will be like this. So its initial position or initial state will be at this point, Vi, and final state will be at this point, Vf. Volume is changing from one point to another, keeping pressure to be constant. Similarly, in this part, but in third, according to ideal gas equation, PV equals to nRT. Since this relation between volume and temperature, so move volume and temperature to one side. So you'll get volume divided by temperature equals to nR divided by P. Now, in this expression, volume divided by temperature is simply perpendicular by base related to this graph, which may define slope of this particular graph, and which is related inversely proportional to pressure. So from this part, we can say slope of volume versus temperature is inversely proportional to this. So greater the slope of the curve, it will have smaller pressure. Hamza, is it clear?
Yes, sir.
Next, we have to define for pressure versus volume curve. First is slope of pressure versus volume curve. dP divided by dV, which is equals to tan theta related to this part. And since this line is parallel to x-axis, so its inclination will be 0 degree and tan 0 will be 0. It means slope of P versus V related to isobaric process will be 0. Now using this, we may define its bulk modulus. So next is bulk modulus. According to the concept of bulk modulus, which is equals to pressure divided by volumetric strain. So if you simplify it further, you'll get delta P divided by delta V multiplied by V. And in terms of differential part, it may be written as dP over dV multiplied by V equals to bulk modulus. I'm using this expression. So beta equals to minus of dP by dV multiplied by volume. dP by dV is nothing but slope of this particular graph, which is 0, with multiplied by volume, so it will become 0. It means modulus of elasticity of this process is 0. It means there is no elasticity of this process. There is no elasticity of this particular process. Khalid, is it clear?
Yes, sir.
Okay, just write it down. Hamza, done?
Yes, sir. Done.
Next, related to pressure versus volume graph, we have to calculate work done. So next part is work done. Work done is equals to area under pressure versus volume graph. So it will be equals to P, which is constant. So it will be V final minus V initial. This may also be written as PV is equals to nRT. So it will be nR temperature T2 minus T1. So by using P times V final V initial, or by using nRT final minus T initial, you'll get work done related to this part. Next, heat supplied or ejected for this process. Heat as dq equals to n times C dt, where C is molar specific heat related to that process. And this is isobaric, so C will be Cp. Now, if you put these terms in first law, you'll get a relation dq equals to gamma times du, which is equals to gamma divided by gamma minus 1 times dw. So this is a relationship between these three different quantities related to gamma. Is it clear?
Yes, sir.
Just write it down, then I'm giving you some problem related to this part.
Sir, can you explain the heat part again?
Just 1 minute. According to the formula, heat supplied or ejected is simply equals to n number of moles, and C is specific heat related to that process, and dt is temperature difference. So in this part, which is isobaric in nature, so C will be Cp. So dq will be equals to n times Cp times dt. Now next, how I have just derived this particular result. du equals to n times r divided by gamma minus 1 times dt, which I have already defined you in last class. dq will be equals to n times Cp, which is equals to gamma times r by gamma minus 1 dt, which I have defined you in the above part in this process. So if you divide these two expressions, nr divided by gamma minus 1 dt will cancel out. So you're left with du divided by dq, which is equals to 1 by gamma. That's why dq will be equals to gamma times du. Is it clear?
Yes, sir.
Iba? In last class, I defined you how to calculate heat, work done, and internal energy. Just 1 minute. This was the formula how to calculate heat. So C will depend upon process in which we are calculating. So if the process is isobaric, so C will be Cp. If the process is isochoric, isothermal, adiabatic, C will change according to the process. So in this part, we are doing in isobaric, so it will be just Cp. Is it clear?
Yes, sir.
Okay. Now related to this part, suppose for helium, from graph, try to find first work done, second heat supplied or ejected, and third change in internal energy. Work done will be simply area under the graph. So try to calculate area of this particular curve using the above formula. 1 atm equals to 10 to the power 5 Pascal, and 1 centimeter cube equals to 10 to the power minus 6 meter cube. Just use these two terms to transform these terms into SI unit and try to calculate. Now, one more thing. This graph is for helium, which is monoatomic gas. And for monoatomic, degree of freedom will be 3. So gamma will be equals to 1 plus 2 by F, that will be 5 by 3. So use this gamma to find heat change in internal energy related to the above equation. Hamza, any doubt?
No, sir, no doubt.
Okay. Just solve, I'm coming just 5 minutes, okay? Hello? Got any answer? Hamza,
Yes, sir. For the first one, I got.
just tell me.
So minus 24.94 to the power minus 4.
Why is it minus?
Oh, okay. I made a mistake.
So for calculation of work done, you have to just calculate area under this PV curve. So formula is P times V final minus V initial. And pressure we have in this part is 2 atm. So 2 into 10 to the power 5. Final volume is 50. Initial volume is 20. And to convert the centimeter cube into meter cube, just multiply it by 10 to the power minus 6. Now, so just simplify this. 2 into 10 to the power 5, 50 minus 20, it will be 30. 10 to the power minus 6. So 2 into 30, it will be 60. 10 to the power plus 5 minus 6, it will be minus 1. That is 60 into 1 by 10. That will be just 6 joule. Khalid, you got this answer or something else?
Yes, sir. I got the same answer.
Good. Now, how to calculate heat supplied or change in internal energy? So according to this formula, dq equals to gamma divided by gamma minus 1 times dw. Gamma in this part, we have 5 by 3. Divide by, if you subtract gamma minus 1, so you'll get 2 by 3 multiplied by work done, that is 6. So 3 and 3 will cancel out. So 5 by 2 multiplied by 6, that is 15 joule. Now use first law to find internal energy. Hiba, is it clear?
Yes, sir.
So according to first law of thermodynamics, dq equals to du plus dw. dq we have 15 joule, du we have to calculate, and dw is 6. So du will be equals to 15 minus 6, that is 9 joule. Khalid, any doubt?
No, sir.
Hamza, done?
Yes, sir.
Okay. So this is all about isobaric process or constant process, constant pressure. Next is isochoric, which is also called isometric process. Gay-Lussac's law. It states the process which is carried out at constant pressure, constant volume is called isochoric process. So it is the process which is carried out at constant volume. So in this part, volume is constant. So according to ideal gas equation, PV equals to nRT. Since volume is constant, so pressure and temperature will be directly proportional to each other. So you may write equation of state as pressure directly proportional to temperature. So P1 divided by T1 must equals to P2 divided by T2. So this will be equation of state related to this part. Now for general equation, we have P to the power 1 by X, V equals to constant. So what should be the value of X so that component of pressure will get vanished out and you're left with volume equals to constant. So if you put the value of X to be infinity, 1 by infinity becomes 0. P to the power 0 will be 1, so V will be constant. So X in this part will be infinity. So using this, we may write molar specific heat at constant volume. C equals to R divided by gamma minus 1 minus R divided by X minus 1. So if X in this part is infinity, infinity minus 1 will be infinity, and 1 by infinity or any number divided by infinity will be 0. So you're left with just R by gamma minus 1, and it will also equals to F by 2 times R. Since this particular process is isochoric, that is at constant volume, so C will be CV. Hamza, any doubt?
No, sir.
Okay, just write it down. Hiba, done?
Yes, sir. Done.
Okay, So next is indicator diagram related to this process. First is pressure versus volume. Second is volume versus temperature. And third is pressure versus temperature. First part, since volume is constant, so graph will be a straight line parallel to opposite axis like this. In second part, volume is constant, so it will be again a straight line parallel to opposite axis like this. And similarly in third part, since pressure and temperature is directly proportional to each other, so it will be a straight line passing through origin like this. So from this part, this line is inclined perpendicular to x-axis, so its inclination will be 90 degree. Graph will move along this way. In second part, since volume is constant, so it will be a straight line parallel to opposite axis. In third part, PV equals to nRT. Since pressure and temperature is directly proportional, so you may write pressure divided by temperature equals to nR divided by volume. Now this quantity related to this curve is defining nothing but slope, and which is related with volume as inversely proportional. So we can say greater the slope of pressure versus temperature, it will have smaller volume. So slope, this curve is inversely proportional to volume. Khalid, any doubt?
No, sir.
Next, we have to calculate for pressure versus volume. First is slope of pressure versus volume graph. So dP by dV will be tan theta, and theta in this part is 90 degree. Tan 90 is infinite. It means slope of this particular curve is infinite. Next, related to this part, we have to calculate bulk modulus to define its elastic behavior. So bulk modulus beta equals to minus of dP by dV multiplied by V. So dP by dV is infinite, so it will become infinite. It means if modulus of elasticity of a particular material is infinite, it means it behaves as perfectly rigid body. So we can say this process will act as perfectly rigid system. Hamza, any doubt? Okay, just write it
No,
down to
sir.
the Hamza, done?
Yes, sir.
Now, related to the above graph, we have to define for A and B, which having more volume, A or B. Since slope of curve is inversely proportional to volume. So first tell me which of these two lines having more slope. Slope means its inclination with respect to x-axis. Which having more inclination with respect to x-axis, A or B? Iba?
The A.
Means inclination of A is more as compared to B with respect to x-axis. Angle of A with respect to this axis, that is this point to this point, and angle of inclination of B with respect to x-axis, that is this much. Which is greater, A or B? Good. And according to the above formula, slope is inversely proportional to volume. So greater the slope, it will have smaller volume. So from this part, we can say slope of B is greater as compared to slope of A. Therefore, volume of A will be greater as compared to volume of B. Salman, is it clear? Okay. Khalid, any doubt?
No, sir.
Next, related to volume pressure curve, we have to calculate work done. Since in this process, change in volume is zero, so there will be no any area inscribed between pressure versus volume curve. So work done in this process is zero. Now, according to first law, we can say dq equals to du plus dw. So work done in this case is zero. Heat supplied in this process will be Nc dt, where C is molar specific heat at constant volume. So it will be Cv equals to du. That's why du equals to N times Cv dt. Iba, is it clear?
Yes, sir.
Just write it down. Hamza, done?
Yes, sir. Done.
Now, there will be some theoretical question related to this process. First is, why on long drive tire of vehicle got burst? Any idea?
Due to excessive heat.
Due to
Excessive heat.
due to a specific heat. Okay. From where it has generated?
No, not specific. Excessive heat. More heat.
Due to excess heat. Then what would be the source of excess heat generation? Let me define you. Suppose this is wheel of any vehicle. So on moving on the surface, there is friction in between these two surfaces in contact. That friction will cause us to produce heat during its motion. And that heat will be responsible to heat up air inside this tire. And since volume of this particular tire is constant, so at constant volume, pressure and temperature will be directly proportional according to this law. So the more increase in temperature will leads to more increase in pressure. And if it will become insufficient pressure inside this tire, it got burst. Is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Okay. So you may define as there is friction between tire and road. So heat produced during traveling will cause to rise in temperature of gas inside. And at constant volume, pressure is directly proportional to temperature. Hence, pressure increases which causes tires to got burst. Hiba, any doubt?
No, sir.
Okay. Hamza, done?
Yes, sir.
Next question related to these two processes will be to define why Cp is greater than Cv, or what would be the relation between Cp and Cv. So next, why Cp is greater than Cv. Suppose in this part, we have constant volume of this particular piston. So at constant volume, dq equals to du plus dw. So dw in this part will be 0 since there is no change in its volume. So if we supply heat into this part at constant volume, the total amount of heat will be utilized only in changing its external energy. That is, if you have supplied 10 joule heat, this entire 10 joule will convert it into internal energy. So internal energy in this process will be 10 joule. But at constant pressure, dq equals to du plus dw. If you supply heat as 10 joule, some of it may be utilized in changing external energy and some may be utilized in doing work as well. So this 10 joule may be converted into 7 joule internal energy and 3 joule in doing work. Now, if you have to get same amount of internal energy in this process, so you must have to supply some extra amount of heat into the system. So let me define you. Suppose we have supplied 15 joule energy into this system. At this case, change in internal energy will be 10 joule and rest of the 5 joule will be in doing work. So on comparing these two processes, since we have to change internal energy of gas by same amount, 10 joule and 10 joule in both cases. So heat supplied in this process is 10 joule, but in this process is 15 joule. That's why Cp is greater than Cv. Is it clear?
Yes, sir.
So we can say at constant pressure, the amount of heat supplied to the system is utilized in two different processes. So to have same amount of change in internal energy in both these two different processes, you must have to supply some extra amount of heat at constant pressure so that some of heat may convert it into doing work also. So we may define from this part at constant volume, heat supplied to the system is utilized in changing internal energy only. But at constant pressure, heat supplied is utilized in changing internal energy as well as doing work. So to get same amount change in internal energy, heat supplied or simply more heat will be required at constant pressure. Hence, Cp is greater than Cv. Iba, is it clear?
Yes, sir.
Okay. Khalid, done?
Yes, sir.
Next, we have to define this particular part mathematically. So let me define you how to solve. First, at constant volume, dq equals to du plus dw. Since work done will be 0, so heat supplied is equals to change in its internal energy. Let's say this is equation first. Now at pressure constant, dq equals to du plus dw. We may write dq as number of moles C dt. C in this part is Cp. Du according to first equation is NCV dt, and work done is simply P times dV. Now we have to transform this PdV in some different part as compared to or as related to temperature. So according to ideal gas equation, PV is equals to nRT. Since we have to get PdV, so in this part, pressure is constant. So volume and temperature will be variable. So differentiating with respect to temperature. So P is constant, differentiation of volume with respect to temperature is equals to nR being constant and differentiation of temperature will be just 1. So P multiplied by dV in this part, on moving dt to right side, you will get this expression. Now put this value of PdV in this part. So NCP dt equals to NCV dt, and in place of PdV, we may write NR dt. Now N dt will cancel out on either side. So you will left with Cp equals to Cv plus R. So from this, we may say Cp is greater than Cv by R. This is also called Mayer's relation. Hamza, any doubt?
No, sir.
Okay.
Yes, sir.
Okay. So this is all about isochoric process and its related problem. Next is isothermal. Which is also called Boyle's law. So it says the process which is carried out at constant temperature is called isothermal process. The process which is carried out at constant temperature. So in this part, temperature is constant. So according to ideal gas equation, PV equals to nRT. So if T is constant, pressure and volume must be inversely proportional to each other so that their product will be constant. So we may write pressure inversely proportional to volume, or P1 V1 must equals to P2 V2. This will be termed as equation of state. Next, to define molar specific heat related to this process, according to general equation, PV equals to constant. So what should be the value of X so that the product of P and V becomes constant? So it must be 1. So if you put the value of X in general expression of molar specific heat, so molar specific heat at constant temperature, it will be C equals to R divided by gamma minus 1, R divided by X minus 1, where X is 1, so 1 minus 1 will be 0, and any number divided by 0 will be infinite, so it will be infinite. It means molar specific heat at constant temperature of gas will be infinite. Hamza, any doubt?
No, sir.
Next, related to this part, we have to plot indicator diagram. Pressure versus volume, pressure versus temperature, volume versus temperature. Since pressure and temperature is inversely proportional, so related graph will be rectangular hyperbola like this. In second part, for some other temperature, related curve will be like this. Now we have to define which of these two curves is at higher temperature or which is at lower temperature. Let's say this is T1 and this is T2. So just draw a line from this origin to intersect these two curves at two distinct points. So the first part, this one, just draw. So it will be V1 and P1. Similarly, for second curve, it will be V2 and P2. Now from this curve, we can say V2 is greater than V1 and similarly P2 is greater than P1. So product of P1 V1 should be smaller as compared to P2 V2. So from this part, we can say P2 V2 is greater than P1 V1. And since PV is equals to nRT, so P2 must be greater than T1. Khalid, is it clear?
Yes, sir.
Next, pressure versus temperature. Since temperature is constant, so it will be a straight line. And since volume is increasing, so pressure must be decreasing like this. Similarly, in third part, it will be a straight line parallel to opposite coordinate, and it is expanding, so it will be along this way. So these are different indicator diagram related to this process. Just write it down. Hamza, done?
Yes, sir. Done.
Okay. Now related to pressure versus volume curve, first we have to calculate slope of pressure versus volume graph. According to the relation between pressure and volume, P multiplied by V is equals to constant. So just differentiate this part, differentiating with respect to volume. So we have two different quantity and they are in product. So we must use product rule. That is differentiation of first term multiplied by second one plus differentiation of second term multiplied by first equals to differentiation of any constant term is 0. This quantity and this quantity will cancel out. So it will become just 1. So dP by dV multiplied by V equals to minus P. So we have to calculate slope. So dP by dV equals to minus of P by V. So this is slope of isothermal curve. So in this part, dP by dV is equals to minus of P by V. Next, related to this part, we have to define bulk modulus. So next, beta equals to minus of dp by dv multiplied by v minus dp by dv, we have minus of p by v multiplied by v, minus minus cancel out, v and v cancel out. So it will be just equals to p. It means beta for isothermal process is equivalent to pressure of the gas at that instant. Iba, any doubt? Okay, just write it down to this part. Hamza, done?
Yes, student.
Next, the most important part of this isothermal process is calculation of work done. So in your upcoming examination from this chapter, you'll be asked to derive work done during isothermal process. So let me define you how to derive. Next is work done during isothermal process. As work done equals to pressure times dV integration. Since in this integration, we have two different variables, P and V. So you must have to relate any one of the quantity with respect to another term so that to change two different variable into single one. So according to ideal gas equation, we may write PV equals to nRT. So P equals to nRT divided by V. So substitute the value of P as this term in this part. So in left hand side, dW on integrating will be W. In place of P, it will be nRT dV divided by V. Limit of this volume will be from V initial to V final. Now this is integration of dx by x type. So integration of dx by x is equals to Khalid. Do you know this particular formula? What would be the
Sorry,
integration
sir.
of dx by x?
Sir, D.
Integration of dx over x will be, it will be ln x. That is natural log of x. Okay.
Yes, sir.
Similarly, by using this property, we may write this as nRT dv over v will be ln v with limit v final by v initial. Now put that limit, nRT being constant, ln V final minus ln V initial. So from this part, let me define your property of log. Log m minus log n is equals to log m by n. Similarly, by using this property, we may write nRT and ln V final divided by V initial. So this will be a final expression of work done during this isothermal process. Iba, any doubt?
No, sir.
Okay. Hamza, done?
Yes, sir. Done.
Now related to this part, there will be a question. This is pressure versus volume. Gas initially at this point, let's say A, during isothermal process, move to this point B. Pressure at point A is 2 atm. Volume at point A is 20 centimeter cube and at B is 40 centimeter cube. So from graph, find first pressure at point B, second work done during this process. So let me define you how to calculate. For pressure, first use equation of state. Since this is isothermal process, so equation of state will be P1V1 equals to P2V2. P1V1 is pressure and volume at point A. P2V2 is pressure and volume at point B. So we have pressure at point A and we have to calculate pressure for point B. Rest of the all point P we have given. Just put their values and simplify it. You'll get pressure at point B. Hiba, is it clear? First, try to find this part.
Sir, do we have to convert the atomic pressure into Pascal?
Yes, all quantities should be in their SI unit. Khalid, you got any answer?
Yes, sir.
Just tell me. Pressure at point B will be good. Hiba, you got any answer? Hamza?
Almost near.
Okay. Just see for first part, P1, that is pressure at point A, which is 2 atm. So 2 in 10 is power 5. Volume at this point is 20 centimeter cube, that is 10 to the power minus 6. Pressure at point B we have to calculate, and volume at this point is 40 into 10 to the power minus 6. So PB equals to 2 into 10 to the power 5, 20 into 10 to the power minus 6, divide by 40 into 10 to the power minus 6. So 10 to the power minus 6, 10 to the power minus 6 will cancel out. 2 into 20, 40, and 40 will cancel out. So you're left with just 1 into 10 to the power 5 Pascal. Hamza, you got this or something else?
Yes, sir, got this.
Good. Next, how to calculate work done for this process. So according to above formula, work done equals to nRT ln V final divided by V initial. In this expression, we don't have any N, R, and T according to this graph. So first, we have to convert this particular notation in some other form. According to ideal gas equation, PV is equals to nRT. So in place of nRT, we may write P into V. So this particular term may also be written as pressure times volume. So the next question will be which pressure and which volume. So you will say pressure and volume of any one point. So in this part, we have two different points, A and B. So you will say P1 V1 or P2 V2 according to your choice. Now put these values and simplify it. ln2 is equals to 0.7. You may use this in this expression. Try to solve. Let me solve this part. Hamza, just tell me the value of P1 and V1 from this graph. That is for point A. The value of pressure is
20 into 10 to the power 4.
I'm asking about pressure at point A. That is 2 atm. So 2 into 10 to the power 5. And volume at this point is 20 into 10 to the power minus 6. Is it clear?
Yes, sir.
Next, volume final, that is at point B, 40 into 10 to the power minus 6. And volume initial, 20 into 10 to the power minus 6. So 2 into 20, it will be 40. 10 to the power plus 5 and 10 to the power minus 6, it will be minus 1 ln 40 by 2, 20, it will be just 2. And 10 to the power minus 6, 10 to the power minus 6 will cancel out. Next, 40, 10 to the power minus 1 will be 1 by 10. And ln 2 is 0.7. So this 0 and this 0 will cancel out. 4 into 7, it will be 28. That is 2.8 joule. So this will be the final work done related to this process. Khalid, any doubt?
No, sir.
Just write it down. Hiba, done?
Yes, sir, done.
Any doubt up to this part?
No, sir.
Next is calculation of internal energy during some process. First, during fusion. Fusion is conversion of ice into water. So according to first law, we may write dq equals to du plus dw. dq will be equals to mass of ice to be melted times latent heat of fusion constant. du we have to calculate, and work done will be P V final minus V initial. So you'll be able to calculate du from this part. During vaporization, that is conversion of water into vapor. According to this, dq equals to du plus dw. du we have mass of water multiplied by latent heat of vaporization. du we have to calculate, and dw will be P V final minus V initial. So mass of water and rest of the term will be given. You'll get change in internal energy during these two different processes. In case of gas, since there is no change in state, so temperature, or there will be no change in temperature, so internal energy will be zero in isothermal process. So using first law for gas, as temperature is constant, so du will be zero. So according to first law, dq equals to du plus dw. Since this is zero, so dw must equals to dq, or dq must equals to dw. So dq equals to dw equals to nRT ln V final divided by V initial. This will be total work done as well as total heat supplied during this process. Is it clear? Hamza, any doubt?
No, sir.
Just write it down. There will be problems related to this process.
And sir.
Okay. Now let me give you a question related to this part. Find change in internal energy on melting of 1 gram ice if volume changes by 10 centimeter cube. So according to the above formula for fusion, we may write dq equals to du plus dw. dq in this process will be mass of ice to be melted times latent of fusion constant. du we have to calculate P times change in volume, that is V final minus V initial. So mass of ice melted in this part is 1 gram and latent state of fusion constant is 80 calorie per gram. To convert calorie into joule, just multiply it by 4.2. du we have to calculate, and this process will carried out at 1 atm. So it will be 1 into 10 to the power 5. Change in volume in this part is 10 to the power minus 6. So just multiply this. 8 into 2, 16. 8 into 4, 32 plus 1, 33. du plus, if you multiply this part, 10 to the power plus 6 and 10 to the power minus 6, it will be just 1. So change in internal energy during this process will be 335 joule. So you'll be asked to calculate these type of problem related to conversion of ice into water or water into vapor. Hamza, any doubt?
No, sir.
Khalid, is it clear?
Yes, sir.
Okay. Hamza, done?
Yes, sir. Done.
Any doubt up to this part?
No, sir.
Okay, so let's stop here for today. In next class, we'll start with new topic, that is adiabatic process. And the last part of this chapter is heat engine. Okay. Okay then, take care. Good night. Love is.
Allah Hafiz, sir.
Thank you, sir. Allah Hafiz.